All right, I just want to go through some story problems here and keep working with these as we go through the chapter. So the first thing we looked at was writing an integer to represent a situation. So we want to look at some key terms and represent it with either a positive integer or a negative integer. So in example a withdraw, right, meaning we take it out of our bank account, that would be negative 100 to represent that. The term for putting money in would be a deposit, so that'd be positive 25, right? And remember, we can write that as just 25, or you can write it as positive 25. Talking about going up and down, descent is going down, so that would be represented by negative 35. Oh, there we go again. Negative 35 feet. A drop of, and let me go back to descent. So you hear that a lot with like a mountain climber or an airplane descending to the ground. We got to know that that is negative. Ascending would be going up. A drop of 15 degrees, right? That would be positive 15. And a rise of 18 feet would be positive 18. All right, in the next two, we want to write an expression to represent the situation. So take a minute and see if you can do 2 and 3. And we'll talk about the different options that you have for that. So the first one says Erica has $32 in her purse. She pays $28 for her lunch. Write an expression to represent the situation. All right, and I want to see if you can write two different expressions that mean that are actually equivalent, but write it in two different ways. All right, so for number 2, we start with $32 in the purse, and she pays $28 for lunch. So I could say that that is minus $28 from that 32, or I could say that I start with $32 and I'm adding to that a negative 28, right? It's a charge of $28, so I represent that with negative. So either of those would model that situation. It says Bill owes Steve $15, but he has $22 in his bank account. Write an equation to represent the situation. So he owes Steve, but he has $22 in his account, right? So that's one way we could do that, right? Remember, with addition, order doesn't matter. I could have said, right, just reversing it. I start with $22, but I owe 15, or I start with $22 and I'm adding to that a negative charge that I owe to Bill. Any of those would model that situation. All right, and we talked about difference between elevations, right? It says the highest point in the town is 55 feet above sea level, right? So we'd represent that as a 55. And the lowest point is 22 feet below, right? So I'm going to subtract, and 22 feet below is negative 22, right? We said with a number line helps us visualize this. And maybe, let me back that up. Let's do a vertical number line, which we haven't really looked at. But if this is sea level at 0, and I have this 55 feet above, and then below sea level would be negative 22, right? And I want to find the difference, or the distance between those, right? Just to go from here to sea level is 22, and to go from sea level up to that high point is 55. So I can see that it's 77 feet between those highest and lowest points, right? And that's the same thing we get if we did the expression over here, right? Where we go leave change to addition. Opposite of negative 22 is positive 22. So we get 77 feet. All right, see if you can use that same logic, whether you use a number line or whether you use the arithmetic, and find the answer to number 5 here. All right, should have gotten 88 degrees for that, right? Whether you did the 85 minus the negative 3 to find the difference between them, or if you just drew it out and said, all right, there's 3 degrees to climb to 0, and then 80, oh, I wrote 88 here, what the total, and then 85 more, which would be a total of 88 degree difference between negative 3 and 85.